All right, welcome to the lunchtime video. We got about 3 months to go before the test. Haven't scheduled the test yet. I figure, well, I heard from my former coworker now, unfortunately. Unfortunately, because studying for a exam like this on your own is more difficult than if you've got someone who's also studying it. But I can definitely contact him on LinkedIn or whatever. All right, so yeah, I've heard that it's not a good idea to schedule your test too far in advance. So even though it's 3 months out, I'm going to wait until it's about 1 month out to schedule it. Even though there already is 1 slot taken and there's only a total of 4 slots available. You know what I'm going to do, just because I'm paranoid? I'm just going to see how many slots are taken right now. And if there's still just that 1 slot taken, I can kind of relax a little bit. So I'll share my screen and I'll check that to start the video. It's important to constantly keep an eye on that. So here's the Juniper website. Let's go to the JNCIE section. Yep. Okay, so let's click exam registration, and let's make sure to click it for the 961. So we've got 3 links here. We've got one for recertification, one for 961, and one for 960, looks like. So let's click the one for 961, even though I believe they all go to the same place, which has a link to go somewhere else. Okay, so the only date that's going to work for me, unfortunately, is this one here. So let's check if there are still slots available. Yep, service provider routing and switching expert. They're also offering different exams. Probably all be in the same room together. Oh, so it looks like it just took me back to the page I was at before. Let's just try going back. Here we go. So registration limit 4, still only 1 currently registered. So yeah, I think I can wait another month or 2 to register. And with COVID-19, you know, who knows what's going to happen in that time. You can see it's very expensive, kind of upsettingly expensive, to the point where I don't know if I can even afford a retake. And then, of course, this does not include hotel fees, travel arrangements. This test is really meant to be taken by somebody whose employer will cover the costs. And that was the situation I was in for the most of my study time. But I'm no longer in that situation because I wanted more remote work. So I needed to change my employer to get that. So this is going to be on me, but I think I'll take the hit for the first try. I don't know if I can afford a retake, but I'll have, if anything else, this video series to prove that I did put the time into studying. And although I might not be completely up to the level of IE because I didn't pass the exam, I am very nearly there. And whatever score I get, if it's passing, excellent. But if it's not passing, you can see, yes, I am, 89% of a JNCIE-SP. All right. So let's continue on then. Really no time to waste, except for a brief moment to refill my water. So I'm gonna reboot my lab just because I want that 6 minutes to go by as fast as possible. Yeah, still no word on my cron job. I had it set up before. I tried to set up again and it didn't work. So it's just going to take a lot of investigation, which this is really not warranted. And it's a good thing I checked that because I was in the living room earlier, or yesterday, last evening, I was in the living room and I walked over by my lab and it just happens to be sitting on the floor. So I stepped on the power cable came dislodged. So I plugged it back in. Hopefully there's no issues, but the lab did power down. So that did actually, I used to have a VPN virtual machine on here and it did tank the virtual machine, but I did this once before in the GNS VM, had no issues. So hopefully it will have no issues again. But in the meantime, let's pull up the documentation I was working off of. So IGP is the section we're doing now. And we're doing configuration and troubleshooting. We've got 1, 2, 3, 4, 5 topics left. Right now we're working on level area mismatches. So we're into the third video. Last video we looked at now we just did OSPF version 3, but it's going to be pretty much the same. I don't know why this green thing is here. Oh, maybe because I edited it from a different device or something. Or yeah, I probably edited it from a different account. I don't know. But anyway, let's copy the goals over because we're going to be working on the same goals this video, except for we'll be moving on to stub area mismatches. And then we'll be doing the same tags. Okay, and at this point I will take a 1-minute break and go fill up my water. All right, so I'm back. So let's see how far along it's. Okay, it looks like it's all the way up. So let's open up the lab. Hopefully the devices are up already. Nope, it's going to take a little bit longer than that. Okay, so while we wait, we can certainly make good use of the time. We'll just remember what the topology was like before. So we've got all these links in area 0. Then we've got this link here in the center in area 1. So we can make this area a stub link. So, you know, it's confusing because if you're used to thinking of areas as something a device belongs to, that's going to serve you well when you're learning about ISAS, but OSPF, that's a misconception. You really can't think of areas in terms of a device. You've got to think of it in terms of ports. So this device here is in area 0 and it's in area 1, as is this device. This is a ABR, area border router, as is AR1, but these are just internal routers to the backbone area, R2 and R3, because all of their links are in router 0. All right, hopefully these are up now. Oops, so we're loading the BM SDK module. So that's one of the final steps usually. And then we're going to look at how to, yeah, we're going to look into stub area mismatches. So let's open up router 4 as well. Oops, and I don't see router 4 anywhere. Let's close. There it is. Okay. Perfect. So, all right, let's do the monitor start on the OSPF version 3 trace options file. Okay. Let's do a monitor log, or let's do a show log just to make sure that I've got the, yep, okay. Oh, no, this is what I thought. I named it wrong. I needed OSFP instead of OSPF. Oh, well, now I can't do it right. Would have been nice if I could only do it the correct way before. Okay, so yep, now we've got our messages because we're looking at the correct log. So let's see what happens if I make the link on this side a stub, but not on the other side. Oh, this is interesting. So I think I might have rolled back my configuration. Oh, I see. I'm in OSPF 3. There we go. So now I have, oh, but even here I only have area 0. So let's create an area 1. Because we can't have the backbone area be a stub area. It has to be a non-stub area. Okay, so let's do run show int description type match R4. Okay, so now delete area. Why can't I do area? I can't do area. Oh, right, gotta do edit OSPF 3. There we go, delete area 0000, interface 001. Okay, and now we're going to add this to area 1. So we should see some mismatch messages triggering on router 4. Not yet, because I didn't commit it, of course, but we should see those eventually once I commit. Let's keep an eye out for those. This is what we saw in the last video. There it is. So let's do a monitor stop, or let's just go up. So here we go, area mismatch, perfect. Okay, so that file is rolling over, so we're going to need to wait for that to complete. And then we're going to set the other side to belong to area 1 as well. In the meantime, we can see what options we've got now that it's area 1. Okay, so now I can set the stub. Oh, but it's not going to be for the interface. It's going to be the actual area is where you set what kind of area it is, and then you add interfaces to that area once it's already configured as a stub or not. Okay, so it's logging again. Let's stop the logging and then fix this up. So edit protocols, OSPF 3, area 0000, run show in description, pipe match R1, delete GE002, delete interface, up, set area 1, interface 02, top, run, monitor, start, T-shoot, OSPF 3. Okay, so now we'll get those messages again. So let's do a commit, and we'll see. Let's see if we'll get another mismatch message before we commit. So I don't see any mismatch messages right now. So let's commit. So here we've got a hello from area 1, and it looks like it was absorbed. So I think that means everything's good to go. Do a monitor stop. Perfect. Okay. Perfect. So now what we can do, because we've got those links in an area, we can see in an area other than the backbone area, we can see what happens when we make that other area a stub area on one side but not the other side, and see what kind of messages we get. Here we go. OSPF packet ignored, area stubness mismatch. Excellent. All right. So one thing we can do as well, and you would never be able to do this in production, of course, but on the exam, I can do this because I don't need to worry about losing traffic or affecting the other aspects of my network or anything like that. I don't need to worry about uptime in my exam or SLA requirements. So what I can do is, if I don't see that message, oh, where's that mismatch message, I can go on one of the devices, I can do clear OSPF 3, and then just like database or just whatever, all. And now it's going to just absolutely destroy the buffer on this one. But I'll get a fresh logs where nothing is omitted from the logs because it had already gone through the process and is now in a different state. So if I ever want fresh logs that makes everything nice and clear as to what could be going on, I can always do that on the test. Of course, it's not going to be something I could do in production, but I think on the test where you really just want to pass, you got to use every single trick that's available to you. So we should see a stubness miss. Ah, I thought I saw it. So monitor stop. And another thing I can do, of course, is just do a show log. Okay, pipe match stub. And here we go. Now I've got brand new messages that say that the OSPF packet was ignored because of area stubness. All right, so let's fix the area stubness on this side. And let's start this again, but let's filter it out for stub. Okay, so now it's going to, oh, we got a mismatch again, which is interesting because I thought so this was an interesting message because it said that the packet was ignored because we got an area stubness mismatch from here. So let's take a look at that. And hopefully that corresponds to okay, here we go. So there we go. So the stubs are added. We're all good to go. So let's take a look for this area. What kinds of LSPs are showing up? So let's do show protocol, or let's do show OSPF 3 database area 1, and then maybe brief. Here we go. So here's LSAs. We've got router LSAs, network LSAs, and inter-area prefix LSAs. Let's look at summary. Here we go. So this looks a little bit better. We've got, within our own area, we've got 2 router LSAs, which makes sense because we've got 2 routers in there. We've got 1 network LSA. We've got 10 inter-area prefix LSAs, 1 inter-area prefix LSA, and then externals, we've got 2 link LSAs. So let's take a look at the routing table. All right, so we've got the same routing table we've got before, and you'll notice that we no longer have cost equal paths to these routes because one path is traversing an area, an OSPF area, and the other path is not. So we have the path where it is not traversing an OSPF area because that path has a lower cost. All right. So let's change the type of stub area, and so we've got the trace options going on here. So let's just keep that going and then go over to router 1 and change the type of stub area, and we'll see a mismatch. Oh, and it's not going to be applied to the interface, it's going to be applied to the area. So we can make it a stub area, or we can make it a non-stub area. We can make it a non-stub area, but we don't want to do that. That would be the backbone area. And of course, you could have other areas that are not stub areas. But let's continue on with our stub area. So now we can do summaries and we can do no summaries. So now I believe summaries is what we've got configured already. So if I were to do a show, now summary is not the same thing, it's just a summary of this command. We're not talking about summaries in the same way we would be talking about that here. We're saying we're not going to send, or we are going to send type 3 LSAs. So that's the default option, I believe. So I don't think we'll see a change here. Okay, yep, so it looks the same. But where I do think we'll see a change is if we stray from the default and set this to no summaries. Then we're going to see now this is interesting too, because I thought that both areas had to match. So, oh, actually, that's not true for summaries, no summaries. You only configure that part on the ABR, because the ABR is the one that creates those summaries. So there's no reason you would have to configure summaries or no summaries on an internal router. You just have to configure that on the ABR. But if you configure the ABR to be a stub area, the one of the areas on the ABR, the one that's not the backbone area, you have to configure all routers in that area to also be stub routers. But you only need to configure the ABR if you want to disable type 3 summary LSAs. Okay, so yep, so we can see this is perfectly good configuration, even though I only configured the ABR. I did not configure the, well, this is an ABR too, but from the perspective of area 1, I did not configure the internal router here. So we can see that it went fine, it added stubs, and now hopefully we'll see this summary here change. We'll have 0 network LSAs. Oh, so we do have network LSAs. So it's not how I was expecting. Aha, but we do have fewer inter-area prefix LSAs, which that's probably what I was thinking. That's probably, yeah, 1, 2, 3. Yeah, this is probably a 3. This is a type 4. Yeah. Yeah, they're probably in order of the type. So, yeah. Right. So now we've only got 5 inter-area LSAs or type 3 LSAs. Let's just do a Google search on that quick to verify that an inter-area prefix LSA is a type 3 LSA. Yeah, so, oops, never mind. Now, I think it is going to be a little bit different between version 2 and version 3, but I didn't think it was hugely different. Here we go. So yeah, these are in order. This looks like a good site here. So we've got router LSAs. Network LSAs are type 2 LSAs, not type 3. So yeah, and they're used. Network LSAs are originated by the DR for a broadcast or non-broadcast multi-access network in the area which supports 2 or more routers. The LSA describes all routers connected to the link, including the DR. The LSA's link state ID field is set to the interface ID that the DR has been using in hello packets. No address information is carried in the network LSA. Inter-area prefix LSAs. These LSAs are IPv6 equivalent of IPv4's type 3 summary LSAs. So there we go. And I was correct. Now that we disabled those summaries, we're not going to be sending those anymore. We've got a reduced number of these. I'm kind of surprised that we have any of them. I was expecting to have 0 instead of 5. Yeah, I guess I don't understand why there are still 5 and not 0. Let's try to figure that out. Let's take a look at the routing table. So everything looks the same here. So, okay, so that's okay. We'll leave that as it is for now. So I thought what I would get is instead of these 3 routes here, I would just get a default route to say that these routes were external because they did come externally. Oh, that's interesting. But they do, of course. So you can also learn these internally. So this is all messed up because I have these 2 extra links. It's not using this link the way I'm expecting it to. So I'll just shut down those other links. And I think it'll make a lot more sense after I do that. Set. Oops, actually this is the one that I don't want to be disabled. Okay, perfect. Okay, so now hopefully it's going to look more like how I had imagined it to look. So we would see, oh, so it looks like we still, but if I do a show OSPF 3 neighbor pipe refresh 1, we're gonna see this dead interval decrement all the way down to 0. Oops. Okay, so every 10 seconds when that hello message, it looks like every 9 or 8 seconds, it will, so it looks like those other neighbors actually just went away right away. Right, because I shut down the whole port. So it's not dependent on hearing a hello message. It knows that it's not gonna have a neighbor because the port is shut down, so. it can remove it from that output right away without having to wait for the whole time, for the dead timer to decrement down to 0. Okay, so let's look at the summary again. Aha, so now this looks exactly how I had envisioned it to look. We don't have any inter area LSAs, whereas up here we had 10 inter ER, but then we enabled the stub, but we had those extra links that made things more confusing, so it just went down to 5, but I had expected it to go down to 0 because the topology I expected it to be was different from what it actually was. So let's take a look at the routing table now. Oops, but this is interesting because we don't have a route anymore. So if I were to ping I've got no route to host. Oh, but that's a IPv4 address. Let's do an exit, or actually, yeah, let's do an exit and let's do a show route protocol OSPF 3. Okay. Oh, not direct. We're going to look at local because we want the ones on the interface. We want to try to ping that. Okay, so let's try to ping this. And we'll get that same message, no route to host, but I just wanted to, okay, maybe we won't. Oh, right, and that's because we do have a multicast route here. Also, it's link local, so it's going to be based on the ARP table, not the routing table. Or, well, so okay. IPv6 doesn't have ARP, so obviously it's not based on the ARP table, but it's based on the table that, yeah, so the neighbors table here. So I will see it, yep. So, oops. Pipe match. Yeah, so it's a neighbor across GE002. So I picked the wrong one. Let's try 001. Oops. Okay, let's try 4. Okay, so we don't have an entry for 4, even though 4 is on here. And I'll just, to prove that, I'll copy and paste it. There we go. And then now let's do a ping to this address. And we'll get a yep. Oh, well, actually, never mind. We've got a destination host unreachable. But you can see we do have a special kind of ping. If I were to ping to a different address, this one that is directly connected, you can see we don't have this. Well, here we're getting a successful ping, so of course we're not going to have it. But let me ping to an address where I will have a success. So this one here. There we go. So now So I didn't have a success. Huh. Okay, well, where I was going with this is there's special kinds of ping output. If I were to ping 172.16.0.1 and get a no route to host, but anyways, what I was saying is sometimes you get a different output from ping if you are pinging a unicast, a multicast, or a broadcast address. But clearly something here is happening that I'm not expecting. I was expecting it to have a no route to host instead of a destination host unreachable message. Because I wasn't expecting it to have a route to host. Okay, but that's a good point though. If there is a route to host, let's do a show route on this and see what route to host there is. Oh, so yeah, see, there isn't a route to the host, so I don't know why. I think it's because it's link local. Yep. So it doesn't use the routing table. It uses the. That's kind of what I'm having trouble wrapping my mind around is the fact that if it's a link local address, the language is a little bit different. Like by no route to host, they don't mean no route in the IPv6 routing table. They mean no neighbor cache information, or they yeah. So that wasn't right. But what I'm saying is, even if there's no address in the IPv6 table, if there is neighbor cache information for it, you do have a route to host, even though you don't have a route in your IPv6 table. So a message like this, destination host unreachable, makes a lot of sense because, yep, I do have this. And this is really telling too, because you can see the network it shows, the C304, even though I'm oh, well, that's interesting. Huh. Oh, because that's the only one that I had available. But okay, well, that's interesting. It went with the C. Oh, I bet you I know why I did that, because the link local address is, yeah, well, there's only one link local address on this device now. So I think it's all. So let me know in the comments if you'd like a clarification of everything we just did here. But in summary, we just kind of learned the difference between the inet.6 table for IPv6 and the IPv6 neighbors table, which kind of replaces ARP and maps your link layer addresses to your IPv6 addresses, as opposed to mapping your, yeah, so it maps the MAC addresses, it makes an IPv6 address out of it using the FFFE, and it creates a link local address beginning in FE80, and that mechanism replaces ARP, and that's what allows it to, if I were to ping something like this address here, that's why I'll get back a message that says destination host unreachable, even though I don't have any valid route for that. It's because if I show IPv6 neighbors, Oh, well, okay, now I'm even more confused. But okay, now I'm really confused. Okay, yeah, I guess I'm just confused how it knew on which route there was no host that was reachable. Because now obviously we can tell when I pinged this, it decided to use this for the route. And I think it decided to do that because there's only one interface that's live. So it knows when I'm trying to ping, oh, that's the only interface I can use. So here's the link local address to this interface. This is what I'll use to try to connect to that. Oops, didn't work. So it's connected to a subnet here. So I'll try to use, so the reply from this subnet, destination host unreachable. So hopefully that makes sense, clears some things up. I think the big takeaway is just that you have this IPv6 neighbors table, which replaces ARP. There's no ARP for IPv6, which is a really good improvement because broadcast storms, things that are a big danger risk to your network, are primarily triggered by those ARP broadcast packets. So not having those anymore is a huge improvement. And that the other big takeaway is that your routing table inet.6 isn't the whole story. You can defer to the link local addresses at any time. All right, so hopefully this has been useful. We didn't get, so I've got 5 minutes, so I think I'm gonna try to just real quickly get through this whole topic in 5 minutes, which I think I can do because we saw that it behaved as expected and it dropped the summaries. So let's reverse that. So we're gonna do a rollback 1, show pipe compare. So now we'll add the summaries back in. We'll see the summaries repopulate. Okay, so they came back. So now we're going to do a edit protocols, OSPF 3 area 1, and then we're going to do delete stub, and now we're going to do set a not so stubby area. Okay, so we still got the thing running, the trace options running on the other side. So we're going to see on there, hopefully by now. Yep. So it should fail now because we will need to have it match. Oops, I don't see it failing on this side. So here we have the option for summaries, no summaries as well. But okay, so it didn't fail. So let's take it as word and let's look at what are in here. Okay, so it looks the same. Okay, so let's look at the routing table. Oops, and let's narrow it down for protocol OSPF 3. There we go. So we don't have any routes. Let's look at the summary again. Aha, so now we're missing some LSAs. Okay, so let's configure summaries. Or let's configure no summaries now. So we lost our neighbor. So it is true that it has to be the same on each side. Okay, but I can just change that to an NSSA. It'll remove the stub automatically. So let's commit that, and then we'll see it come back up. And I've got no summaries on there, so the last thing I'll do, hopefully in the 1 minute I have, is set this to summaries. Okay, so we've got no inter area again because we disabled summaries. So let's see if those come back. Okay, let's see if the neighbor comes back. Okay, so we got the neighbor again. Let's look at the routing table. Okay, and the summary. All right, so let's commit this. We got about a minute. And let's check those 3 things again. And then that will be the end of the video. Aha, so now we've got some more routes because we've got those summaries back. So we do get routes for those because they are summary routes. And we also get our neighbor. No changes to that because that will not change the neighbor. So yeah, that's the end of the video. We looked into OSPF stub area mismatches. So next video, we'll be looking into ISIS area mismatches and ISIS level mismatches. So thanks for watching, and I'll see you in the next one.